I have a series, n goes from 1 to infinity, n plus 2 divided by n plus 1 using integral test. So using integral test, I will change the series to a function f of x equals to x plus 2 over x plus 1. We need to check positive, continuous, and decreasing in that interval, x greater than or equal to 1. So when x is greater than or equal to 1, so when x is greater than or equal to 1, and then what happened to the y? X is positive, so you have positive over positive, then the y is positive, then the y is positive. So we say that f, the function, is positive. And then when x is greater than or equal to 1, how about continuous? X is greater than or equal to 1, you don't see any vertical asymptote, right? Because there is only one vertical asymptote when x is equals to -1, but we are using greater than or equal to 1. So f is continuous. The decreasing is always a trouble because you will have to use a derivative, and then the derivative is often need quotient rule, and then f prime of x. So if you don't remember quotient rule, here is the quotient rule. Quotient rule, you have a function divided by another function, take the derivative of that, that is equals to gf prime minus fg prime divided by g squared. And then the function that is equals to -1 divided by x plus 1 square. That is the derivative. And then for x greater than or equal to 1, is that decreasing? Yeah, look at the denominator. The denominator is positive. You have a negative divided by positive. So is f less than, the derivative is less than 0. So therefore, the function is decreasing. You have to process these things all in your mind. Okay, now we check this. Positive, continuous, decreasing. It is okay to start the integral test. And then this is equals to integral from 1 to infinity, x plus 2 divided by x plus 1 dx. It is necessary to set up the improper integral, b approaches to infinity, 1 to be x plus 2 over x plus 1 dx. And then this is a u substitution. We will let u equals to x plus 1, and then du is equals to dx. It looks like that is not going to simplify anything in the integral for you. Okay, in this case, then I will change this x to x equals to u minus 1. How's that? And then we rewrite the integral. So we have integral. The x is u minus 1. And then you have a plus 2 divided by, you already let the denominator be u. And then that is a du. Can we simplify that? Can we have an integral u plus 1 over u du, and that is equals to integral u over u plus 1 over u du, and then this is integral 1 plus 1 over u du. Do you still remember this from your integration technique? And then the integral of 1 is u. The integral of 1 over u is ln absolute value of u. So that is equals to u plus ln absolute value of u. Now we put the x back to it. 1 plus ln. Okay, this is required. X plus 1 in absolute value because ln negative is undefined. The first one is not 1. The first one is supposed to be x plus 1. And then we can put this back to our improper integral. I have limit as b approaches to infinity, x plus 1, and then plus ln, absolute value x plus 1, such that x goes from 1 to b. And then we have plug in infinity plus 1, and then plus ln. Now we can use parentheses, infinity plus 1. And then minus ln, not ln, and then 1 plus 1, and then ln 1 plus 1. This is minus the whole quantity. Oh, there is a plus in there. There is a plus in there. However, this piece, there's one piece. What is this? This is 1 big of an infinity. And then minus 2 plus ln2, or 2 minus ln2. It doesn't matter anymore. You have infinity minus that, and then that is equals to infinity. What is this infinity mean? This infinity means the following. You have a sum. You have a series. I will just copy and paste the series right there. You say that this series is equals to this integral, and then I will put this right there. And then that is equals to, okay, paste, infinity. So that means the area under the curve of the function from 1 to infinity is, from 1 to infinity, the area is infinity. So that is an infinite area or infinite sum. So that means the sum is equals to infinity. The sum is equals to infinity. So that means the series diverges by the integral test. Alright, then that is the end of this problem. Okay, so this one is the end of this problem. I prefer to do one problem in each video, so that won't make the video really long. Okay, I will do another problem in the next video. How about this? I will see you there.